In this video, I'm going to import some data into Mathematica or Wolfram Cloud from a JSON file, and then try to extract some of the numbers within the data and plot those numbers and maybe fit them to something. Okay, so I'm going to read this JSON file I have called planets. This is my sort of version 1, and then I'm going to show you another version. And I may need in the end a third version, but so this is just planets. The other one's going to be planets2. Planets.json is in JSON language an array of objects. Those objects have properties: position, name, image, the velocity and the distance. Those are the sort of more numerical properties that we're going to be interested in. But one of the points that we're going to have to deal with is that this data that I grabbed from somewhere on the internet, even though the velocity and the distance were numerical data, it was had quotes around it. So you can in a JSON notation, your data, like if it's a string data, it definitely needs the quotes around it, but numerical data can be without the quotes or with the quotes, and that's going to be one of the issues we have to deal with. So I have another version of it. Planets2, I edited those two numerical fields and got rid of the quotes, and that's going to make life a little bit easier, but I'm going to show you how to deal with the hard way. And but also, if the data is easier, then there's not quite as many steps to deal with it. Okay, so the first thing is just to bring the data in, and again, I'm bringing in planets.json first. That's the one where there were quotes around the numerical fields. So I'm going to do a shift enter here, and I brought the data in, and there's no sign of those quotes here in what's come in this out1, this thing I've called planets, since coming in. We have sort of a list of lists, and then and we have key value pairs. So we have the key is position, and that leads to the value of 1 for this particular sort of, I don't know, element in my list. Okay, so that's just all of the data. And I can use this sort of like list type approach and say I want the first planet and the 4th field. And so that is this sort of double square bracket and showing me 2 indices. That's a way to access one of the properties, but it's presented to us as a key value pair here. Okay, so now I want to take the data. I want to take the velocity data and distance data and make a list plot. And so I'm going to show you some attempts that don't work, and then an attempt that finally works. And then I'm going to show you the other JSON file, which is a little bit easier to deal with. Okay, so this is me pulling out from this data. It's got Mercury through Neptune, I guess it's Neptune, and then Uranus, Neptune, I guess. And then this data happened to have the 9th value as the sun, and so I don't want the sun. That's not a planet. And it doesn't have Pluto. Makes me cry. Okay. So here's my notation for pulling out the data that I want. So I'll call them rows 1 through 8, and it's got this semicolon, semicolon notation and this double square bracket notation. So that I want rows 1 through 8, and I want columns 4 through 5. Because 4 and 5 were the distance and the velocity, or the velocity and the distance. velocity and distance. Okay, so that pulls out of all this massive data, that pulls out these numerical fields that I want. And then here's my, and you can see it's not going to work. Here's my attempt at a list plot of that data. And it's not working. Okay, so these aren't just simply a list of number pairs, but it's a list of a pair of key value pairs. So I mean, in some sense, velocity arrow 47, and that's a sense of a pair of a key value pair. And then I have a pair of those pairs. And what I'm used to plotting is just a pair of numbers, an X and a Y. So the first attempt didn't work. So now this next attempt is to work with to extract from the key value pairs just the values. And so that is this values method. So I take the same subset of the planet data, but I'm going to just take the values of it and do a shift enter. There it is. Now, if you've worked with data and list plotting in Mathematica, then this looks very promising to you, that it is sort of a list of small lists of pairs. And that's usually what the data looks like when you want to print it. But I get this just this graph of nothing. And then I struggled with this for a long time. Now, one thing one can do, because this is so, has the right overall structure, if I were to copy this, like on the little gear here, there's a copy as plain text. If I copied it as plain text and then pasted that plain text in, then I can get a successful plot. So there's something wrong in here. It looks right. And then if I just use the plain text of it, then I can make it work. But it just as is, it's not working. So there's something in here making it not work. And for a while, I was very confused and thought it was the formatting, but it's more to do with the type, that in the original data, in the original JSON data, those numbers came in with quotes around them. So I think it's a type issue. I think it thinks these things are strings. And so it says they're not numbers. I don't know how to plot that. It gives me this empty little plot. So then brings my third attempt. Well, the third attempt I'm going to show you. There are many, many in-between attempts that had got me nowhere. But this attempt, I bring in two expressions. So it's going to turn these things into expressions, something that it wants to evaluate. They're just numbers. So the expression is going to be a number, or if in a programming language, I'd say I'm casting it as a number, converting it to a number, or casting it to a number. But in Mathematica, I use this ToExpression method. And I'm going to shift enter that. And I've called that my third attempt. And now I can list plot my third attempt, and I actually get a plot. And then I decided to go a little bit further and do a FindFit, because I've sometimes had a successful list plot, but there's still something in there that's not numerical. And then when I try to fit the data, something still goes haywire. So just to convince myself completely that it really is just a set of numbers now, and I can fit it, here I am fitting it to a power law. So I'm saying, here's my data, third attempt. I'm using FindFit. I'm using this is a power law, and coefficient times x raised to a power. My coefficients are a and b. I'm giving them starting points of a1 and b minus 1, so I don't have any convergent issues. And my variable is x. And that works, except suddenly I was expecting a -1/2 and got a -2, and that was just my fault. And that I really wanted distance on the x and velocity on the y, and I have the opposite. So glutton for punishment than I am, I decided I wanted to turn it around. And so there's a reverse function. If I just say reverse third attempt, it will just like reverse the order of the pairs, and that doesn't do me any good. That, you know, if I'm plotting them, it doesn't matter. The order doesn't matter. I want the order within the pairs. But if I say reverse third attempt, comma, curly bracket 1, 2, then it reverses sort of in both directions. It reversed the 47 was the first one. So it reversed them within the order of the pairs, but it also reversed the within the pair. And that's what I really wanted. So here I am reversing everything. And then now I can plot, and I call that other way around. And now I can list plot the other way around and label the axes the way I want. The x was distance and the y was the velocity. And I can fit the other way around and get my -1/2 that I wanted. Okay, so that's what I was expecting. That's what I wanted. Okay, so I managed to read a JSON file, to take the rows and columns that I wanted from the JSON file, to get rid of the key value pairs and just have the values, and then make sure they were numbers. And then I also wanted to change the x and the y order here. Okay. All right. So another approach, I had another version of the JSON file where I had access. Well, this JSON file, the original JSON file came from somewhere off the internet, which I just stole. But I took it as it was. And here I actually went in and edited. That's not a usual thing you can do with JSON files. You often have to take what you get. But this one I did have some access to, and I changed these numbers by getting rid of the quotes around the numbers. And so planets 2 is just importing the second JSON, the simpler JSON. And then, so that's planets 2. And now I'm going to do a second attempt at my second attempt. So I'm doing values of planets 2, the first 8 rows, columns 4 and 5. And shift enter. And then I can go straight into the list plot on attempt 2, because I didn't have the problem of them being the wrong type. So all I had to do is pick out the ones I want and get rid of the key value pairs, and I'll keep the values. But because in the original JSON, it was understood as numerical data, then I didn't have that third step here. Okay. That's what I wanted to show you. Read a JSON file, extract parts out of a JSON file. When you read the JSON file, you had key value pairs. Just grab the values and get rid of the keys. And then you might have had sort of string data. And so then the ToExpression dealt with the string problems. And then plotting and reversing orders and fitting to a power law, other fun that I've talked about in other videos. Okay, that's what I wanted to show you. Thanks much for your attention.